Hi everyone, I'm Rajkamalai and welcome back to the brand new series of AI product engineering. And in continuation to that, today I'm going to talk about a brand new topic which is solid principle. This topic is in continuation to the system design playlist that I have started yesterday. So this is the very next topic of system design. So as a whole, where in yesterday's session I talked about, if you look at the high level of system design, it has multiple phases. Like to start with the requirement gathering, then it goes to the capacity planning, then it goes to the HLD, then LLD, then it goes to the basically database design, then API design, and then at the last we talk about infra design. So these are the various phases of any system design. As in when we talk to our stakeholder, talk to our client regarding their requirement. Generally, we follow certain steps, certain phases as part of system design, right? So LLD is one of them, which is very essential at granular level. Whatever the code implementation we are doing, considering the business logic, there. Uh, this is a place where the service. This is the place where solid principle comes into the picture. Okay, so without further delay, let's get started. So guys, I hope you can see my blackboard. So if we'll talk about the system design, right? So there we talked about the requirement gathering and the capacity planning, then HLD, LLD, database design, API design, infra design, and uh, I also iterate that as a part of low level design. This is a place where solid principle come into the picture, and every letter has its significance, be it O, be it L, be it I, or be it D. Every letter has its significance. That's what we call it as a solid principle, which is pretty much essential, pretty much important while developing the code at very granular level, considering all the business logics. Like if we talk about this LLD, so we deal into the classes, object, methods, relationship, data structures, right? So this is what the low level implementation contains. And when we are writing our code, right? So the idea is, with the help of solid principle, what it says, it ensures that your code is maintainable, reusable, flexible, stable. Okay, stable. And there is a concept of coupling and decoupling also come into the picture, which says whatever the, suppose we have written the one big model, one small model. So those, ideally, those two models should work independently. It is not like that they are tightly coupled. If we are making any changes in, suppose, a smaller module, it enforce you as a developer to make the required changes or many changes inside the big modules. As and when wherever you find this kind of dependency, we say that these two modules are tightly coupled, and ideally we should avoid this kind of situation to arise in our code base. So this is what pretty much the core expectation from the solid principle. Whatever the logic, whatever the class, module, function we are writing, it should work independently, right? Because once, in first version of your code based development, your project development, once it goes to the production live, as a maintenance, there will be some demands come where you have to fix some code bugs. You have to work on some of the minor enhancement. So as a part of those minor enhancement development, it should not happen like whatever the changes you are doing, it enforces you to do so many changes at so many places in your existing code base. So those couplings should be avoided. we should write the code in such a manner. So that's where this solid principle comes handy, comes for us to rescue. Okay, so that is pretty much about this solid principle. Now, as a next phase, I'm going to drill down each and every principle as a part of solid principle. What S says, what O says, what L says, what I says, what D says, so that in a more practical manner, we are able to understand the hidden concept behind it. So that you are able to retain these things for a longer period of time, and going forward you just start using this solid principle at the low level implementation in your project, so that your code become very maintainable, very I would say the flexible, very reusable, and very stable. Okay, so let's come to the VS code. So guys, I hope you can see my screen. So here if I'll talk about, here if I'll uh, talk about this solid principle. Okay, so what S stands for? S says every class should have a single responsibility or single jobs to do, right? So in general, as a naive developer or as a beginner, or even the senior developer used to do this kind of mistakes while the development, they usually create a class and keep on adding all the existing functionality as a part of this class. But this is not the correct approach. Ideally, the approach should be a class with its primary responsibility, its primary function to be defined inside that. Okay, or not only one function, there could be multiple function, but it should be very specific to the that class. Here, if you see by looking at this function, at some extent it seems to be related to the student, because here we're talking about the calculate marks, but what about the save through database, right? It could be any admin activity, maintaining the records of the student, similarly sending the email. Again, uh, your school management will be managing this kind of activity, right? So there could be some different class for like admin class, where we can define this kind of function underneath, right? So ideally, that's how we need to proceed. So uh, whatever the function which is very specific to the class, we need to keep inside that. Otherwise, other function we need to just keep in the separate class altogether, so that we are able to meet the first principle, which says every class should have a single responsibility. The correct approach says, for the this mark calculation, we have created a separate class altogether, and we have kept the related functionality inside that. Similarly, for the database handling, we have created separate class altogether, and we have kept a dedicated function inside that. Similarly, for the email sender, for the sending email, we have created separate class altogether, and that's how we have segregated each and every uh, specific functionality inside a different class altogether, so that there is a no dependency. So there is a no dependency of this class on this class. This is how we are also decoupling this class and the related functionalities. So decoupling is something that we have to achieve, right? At the same time, we are segregating a class with its individual responsibility, right? So that is the first principle. Very easy, easy to understand, easy to implement. Now if we talk about second principle, what it says, it says it says open close principle. The principle says software entities like the classes, modules, functions should be open for extension, not closed for the modification, but closed for the modification. What does it mean? Seems very fancy, uh, but yeah, let me break it down for you. So if we'll talk about this thing, So just go down and try to understand this in more detail. Okay, so what it says, generally what we do, generally we create a class and we suppose we create a function calculate discount, okay, with customer type and price, and we are just matching. If the customer type is premium, just put these percent discount on the price. Similarly, if the customer is regular, apply 10% discount. If it is new, apply 15% discount. If it is VIP, apply 25% discount. And if it doesn't fall inside any of these categories, just apply only 5% of the discounts, which is in general discounts for any kind of customers. Here, if you try to understand what all challenges it has, suppose in future if any other new customer got added, it could be uh, suppose it's related to depending upon the its credit history, depending upon its purchasing pattern. We want to classify some customer type, right? Suppose some customer, depending on the credit history, we want to segregate, and we want to give the maximum discount on top of that, right? Or depending upon it's a member membership. If suppose that customer has taken the Amazon Prime membership, right? Some membership, if that kind of labeling has been done with respect to customer, we can apply some different logic for giving the for calculating the price. That could be possible as a part of some future scope of this function implementation, right? But don't you think in order to in order to add those logics, we are making changes in the existing code base itself, and which is not encouraged as part of solid principle. Principle says software entities class module functions should be open for the extension. We want to extend it, want to use it, you're welcome. But it is not encouraging, not recommended to do the modification in the existing class method objects, right? That's what the O principle says, open and closed. So here, if you look at what will be the right approach, what will be the right approach? So as per the right approach, what is going to do, we are going to create a separate class, right? I mean, it's also meeting the S principle as well, keeping the classes with its individual responsibility. So that is also fine. And we are also keeping this thing in mind that open and close principle is also being followed, that it's open for the extension but close for the modification. So both principle we are following here. Ideally, I mean, if you are putting required amount of focus in this practical session, then you will realize that we are I mean, considering both the principle here. So we are just segregating each class with individual responsibilities. So it is for the calculating discount for the regular customer. I mean, the segregation is based on the customer type. Similarly, for the premium customer, we have done created the separate class premium customer discount, and accordingly we have applied the price. Similarly, for the new customer, VIP customer, and the other customers. So, what will the benefit of that? Even if suppose some company membership customer comes into the picture, and then our client says, guys, just implement a logic to give the discount or calculate a discount for calculate the price after discounted price for the our I mean our prime users or our customers which has the membership from us, right? So to implement that kind of logic, we need to separately create a class for that, nothing else, right? We are not going to change existing logic of any existing class. That that thing we are avoiding here, and that's what this principle says, right? That open and close principle, where these classes will be open for the extension, open for the use, but close for the modification. If any modification is required, what we'll be doing, we will be adding new piece of code in terms of the class and respective functions. So here, if we talk about in terms of uh, some prime customer, I would say. So prime is not there, right? Premium, some member, suppose membership kind of, let's say membership customer discount, right? Here we will be just creating a function, just calculate. See, these functions are common, calculate discount. The only matter is the by defining this class, we are just ensuring the different customer type we are covering. So discount, then self price, and accordingly, suppose we want to apply return, sorry, the discount as a, let's say, 0.30%, right? So this could be the logic. So, and then in order to use that, I have created the get discount method, and there I have taken discount and price as two parameter, return discount dot uh, calculate discount function we are calling. So discount is nothing but the customer type. So see, in order to use that, what I have done, get discount method I have called, and for this discounts parameter, what I'm doing here, I'm just creating the object for every individual class. So for, if it is a regular customer type, so we are just creating the object for this regular customer discount, and then we'll sending the price. Let's say for the price is 100%, 100 rupees. Then after applying the regular customer discount, what will be the final price for that, right? So that we are calculating. Similarly, if it is a prime customer discount, we are calculating the object for that. And for the same 100 rupees price, what will be the discount after applying the previous customer discount? Similarly, I can add one one method call for this membership customer discount as well. Let me implement for you. Okay, so let me implement for you. So what I'm trying to do, so here I have already done that. Just let me do one thing, class, and membership, suppose membership customer discount, membership customer discount, and then calculating the discount. Then I have also defined a function in the similar pattern, and here I'm just applying uh, let's say 30% discount. Okay, so 30% discount for the membership customers has been applied. Now I'm also adding one additional function call for this membership customer. Okay, let me run that. See, after giving the 30% discount for their membership existing customer who has the membership uh, um, of the company, right? So in that scenario, what will be the final price after applying the discount? That will be the, suppose discount we are applying, right? So the price will be this 30 rupees, right? 30 rupees discount we will be getting basically here. So that is pretty much clear. Talking about the L, talking about the L, which is nothing but Liskov substitution principle. So Liskov is the person who invented, who come up with this principle, and according to Liskov, what he says, derived or child classes must be able to replace, substitute, reuse their base or parent class. This ensure that any subclass can be used in place of its parent class without causing unexpected behavior in the program. Okay, so let's break it down further to understand. So what it says, suppose I have created a class bird with basic functionality. Suppose bird will fly, right? So fly method I've created. Okay, it's flying. Now I've created another class penguin, which is extending this bird parent class. So now this fly will method will also be available inside penguin to use. Now since penguin is a bird I mean comes under the bird category, but penguin cannot fly. So in that scenario, we are just overriding this parent method, which is not recommended as per the solid principle. The idea is we should define this class and this child class and this inheritance, the I mean we are extending the base class from the child class in such a manner that whatever the methods or function are defined inside the parent class should can be easily reused without changing, without overriding. That's what the principle says. Okay, so if that is not happening, then ideally we need to think and change the design. Okay, so the segregation level should be I mean we have to done at a different level so that we are able to fulfill fulfill the expectation of Liskov substitution principle. So how can we do that? Let's see that as well. So as a part of correct approach, what I have explained that I can create a class bird. I can mention a very common functionality eat. Bird will be eating any bird, be it I mean be that bird is able to fly or not, it doesn't matter. This is the basic necessity of any I mean living being, right? Be it bird or any even for any animal, any kind of. And I have defined this basic functionality eat. Then for the class flying bird, which is extending, which is inheriting uh, its parent class behavior. So this eat functionality will be available to the flying bird. That's fine. No need to override that, right? Because that is pretty much common applicable for the flying bird as well. Then additional function we have defined in the child class, which is fly, because this is a flying bird, right? Okay, then there is a bird sparrow, which can fly, which can eat. So it is extending, which is inheriting this class flying bird. What now it is doing? Now this fly will be available inside here as well. And since we are inheriting or extending this flying bird, and flying bird is inheriting this bird parent class, so eat and the fly, both the methods will be available under this class, right? So I mean both are applicable, right? For the sparrow class, it can eat uh, I mean that bird can fly as well. That's fine pretty much. For the penguin, where these things were failing, breaking earlier in the previous example, which is known as the wrong approach, what we can do, penguin now extending bird class only. So bird has the basic functionality of eat. Eat can we can use. So penguin cannot fly, so we do not implement the fly method inside that. It's optional, right? And that flexibility we have get after segregating or restructuring this function in such a manner that only the common functionality which is common across all the birds we are keeping in the parents. And if there is any functionality which is very specific to a flying bird or non-flying bird, we are keeping that separately, right? That's how we can meet the principle of Liskov substitution principle as well, right? So there we are not changing, I mean we are not overriding basically the methods available in the base class or parent class. We are replacing or substituting or reusing. Just focus on reusing. We are just reusing. I mean, this principle is enabling us to reuse the existing method available inside the parent class. Okay, that's the whole idea. Let's move to the next principle. I hope till here each and everything is pretty much clear in more practical manner. Okay, if I talk about int I, okay, this I am talking about. So I says interface segregation. It states that clients should not be forced to depend on methods that are irrelevant to them, avoiding unnecessary dependencies. So whatever the class we are creating, whatever the function we are defining inside that, if it is related, then it's fine. If some function are not related to that class, don't keep or don't make it a part of that class. That is being strictly instructed as a part of interface segregation principle. Okay, the goal is to prevent fat interfaces by using multiple small client specific interfaces, each with a clear and specific responsibility. So what we are going to do, let's try to understand from this example. So what we have done, we have created a class with worker, and sorry, I have defined a function as a worker. Worker can work, right? That's pretty much fine. Worker can eat. That is also pretty much fine. I mean, it seems this class definition is perfectly fine with respect to this worker class. But see where it got started breaking, where it gets started breaking. So when we are defining this class robot, right? I would say the child class, because it's extending this parent or this parent of base class worker. Now both work and eat function will be available to the robot function, but will robot eat? No, robot is a machine. It doesn't eat, right? So work is fine, that is reusable, but what about eat? Here also we are trying to throwing in an exception, or we're trying to override the definition available inside the parent class, which is not recommended again. So what is the correct approach? See, if we are going to restructure that, the problem will be solved. The problem will be solved. How this problem is going to solve? Let's understand. See, in the current approach, how the segregation happen now, whatever the function I have defined inside the worker class, the work and eat, at that label I have defined the classes. Now if I define the class at work label, at eat label, then if I'm going to create a class of worker, that is a choice of that worker. If we can extend for work and for eating functionality. Similarly, if we're creating separately a robot class, and we have separately creating the class for the work and the eat, then now we are getting the leverage, right? That there is no need of creating the dependency, the coupling thing. We are able to easily get rid of those dependencies, unnecessary dependencies, right? So coupling thing we are able to handle here easily. See what I have done, created the class as a work variable, and the function I have defined work inside that. Similarly, for the eat functionality, I created the separate function eatable, then eat function I have defined inside that. Then I have created a separate function as a worker, and worker can work, can eat. So I'm just extending both the classes. Both the class, if I'm extending, as a part of that inheritance extension, I'm able to use these two function work and eat, and now I can just print some customized message, right? But I'm not changing the definition, the behavior of the parent class, right? That is I mean, something you need to understand here. For the robot, now I'm getting the option that depending upon the robot behavior, I mean, as per the today's era, robot cannot eat, right? What generally human aids. So with respect to that, robot can work. So I'm going to extend, I'm just going to extend this workable class, and as a result of that, I'm just going to use work method. I mean, that is how we can manage these dependencies things, right? Sometimes we need to just go back, step back, and then redesign the solution, right? And that's where this solid principle comes handy to create such kind of maintainable, scalable, reusable, flexible code base, which is, which will live long, and anybody or everybody can start contributing without creating a lot of dependencies, right? In a very modular fashion. Okay, all right. So if I'll go down, so there is last principle, the dependency inversion principle. Let's understand this principle as well. So in dependency inversion principle, what it says, the principle states the high level module should not depend on the low level modules. Again, the coupling thing, right? Instead, both should depend on the abstraction, the interface. This prompts loose coupling and allow for easier maintenance and testing of the code base. That is the whole idea. Let's try to understand with the real-time example so that you will be able to easily relate it. Okay. So generally, for the DB connection, what we do generally, suppose we are using this MySQL database. So I will be creating a separate class for that MySQL DB. Suppose with respect to the saving data, I have created this function. Then in order to use, suppose there is a user, right? So for our user, we are giving the services in terms of the using those databases. So as of now, in order to use a database, I have written this logic. And here, if you see, this user service class is, tightly coupled, or there is so much of dependency on the this class, the separate class, right? So these two classes, this class and this class, these are two classes which are tightly coupled as of now. If you are going to make any changes, right? So accordingly, I need to go and changes here as well. Suppose today I'm using MySQL, tomorrow MongoDB, Cassandra, VectorDB. So I have to go and make the changes into the existing class code, right? Which is not recommended again. What could be the correct approach? Let's break it down. To understand the correct approach, it advises you can write the code like that. Suppose in the future you're going to use MySQL database or MongoDB database, right? It's okay. I mean, just I'm trying to explain you with respect to two databases, right? Then I will scale it further. So suppose what we can do, rather than keeping the creating the dependency of database inside the user service class, what we can do, we can create the separate class for that. So suppose we are using, as per the project requirement, as of now, we generally use two databases very frequently, which is MySQL database and the MongoDB database. For the MySQL, I have defined this save methods. Similarly, for the MongoDB and for the user service, now it's parameterized. It is not depending upon which, if you are going to use MySQL, if you're going to use this MongoDB database, right? So how we are going to, achieve this parameterization? Let's try to understand. So here just we are passing database. So let's try to understand. Suppose in order to use this, call this class, we are creating the object for that user service, and then we are going to pass the database instance. It could be the MySQL, it could be MongoDB, right? I need to only go and create the respective instance of that database class. So for the, if for my project I'm going to use for certain set of tasks MySQL database, I'm going to create the instance for MySQL database, and then it will be calling the save user, which is inside that. And suppose I'm going to save this John Day as a user inside the MySQL database. It is going to pass this thing. this data inside that, so it will be easily able to uh, give you the output as a saving John Day to MySQL database. And similarly, if I'm again sending the same data for the MongoDB, so it will say saving John Day to the MongoDB database, right? So that's how we can just remove the dependency on the uh, this MySQL database that eventually we are end up doing in the previous code, right? So in the previous code, if you're trying to understand here, see the dependency we are creating, unnecessarily dependency we are creating on this MySQL database. Here we are just segregated. We created the two separate classes for the database. Suppose in the future, since we are learning to build end-to-end AI product AI system, so there are the scenarios where we are going to use vector database more frequently, right? So suppose vector database. For that, suppose this is the function I have written, right? And similarly, if I'm going to call this vector database instance as well for saving Alice Doe as a customer, let's see what it returns. Returning saving Alice Doe to the vector database. So here I'm just making the changes for the database instances, whichever the instance I'm going to use in my project. Apart from that, I'm not going to change at the code label. Okay, the only thing I have to create separate classes for the databases so that it can easily scale and it can be easily uh, maintainable going forward as well. So that is the whole idea about the solid principle. I hope you guys have liked the solid principle, which is pretty much important for you as a developer to implement your logic at more granular level. Okay, so guys, I have covered pretty much whatever I have planned for today's session as a part of solid principles. I hope you would have learned something today. With that, I am signing off, but remember, keep learning, keep building, and keep growing together.